Hello everyone, I'm Francis Natwera, explaining the classification of fruits according to freshness using artificial intelligence. The introduction part. Let's say this is a description of the project to come up with an artificial intelligence model, which is to determine the freshness of fruits. From the past series of videos we'll be having, I've been trying to explain a project that is supposed to use artificial intelligence to determine the level of freshness of the fruit. So with this project, we shall be able to determine or classify the different fruits. We're using fruits such as bananas, apples, and oranges to determine whether it's fresh, stale, or rotten. That's the introduction part. Then, if we got the background of our project, it entails from the keywords that we're using. We're using the classification, the freshness, and fruits and AI. Artificial intelligence being a machine learning model that is supposed to use different algorithms and techniques in mimicking the human wisdom or the way humans work. Then for the freshness can be how it determines or it defines how a fruit is the quality of the fruit, whether it is rotten or stale. Then classification, I can explain classifications as separating the fruits, putting them in different levels, putting them in the rotten, and the classification can be done according to the levels of accuracy of our project, levels of accuracy. As for the fruits, we know the fruits are, as I've mentioned, the fruits we shall be using, the bananas, the apples, and the oranges. They are the fruits that our project is tackling. For the strawberry, those are the techniques we're using. Here it's saying supervised learning can be used to train a model on a data set of fruits. Supervised learning is the model to learn the data. That means all the information needed about the data are fed in the model. All, let's say the shape, the color, the texture, all those about the fruit are already saved in the system. So it's all about the model that's being built to determine according to a certain fruit that it is tackling, and it uses its camera to refer to the data that is already in the system to determine on the levels of accuracy whether the fruit is rotten or that is not rotten. Then for the unsupervised learning, can be used to group the different fruits with similar features into clusters. So for the research gaps involved in the system, have the limited availability of data sets, the need for feature engineering, variability in fruit characteristics, interpretability, and then scalability. If I can start with the scalability. Scalability in machine learning refers to the scaling or the machine learning applications that can handle any amount or maybe large sums of data and perform many computations in a cost-effective or time-saving way. So that means the gaps involved. This can be like disadvantages. That means you need to have those costs, the way of saving those costs in our model. Then we have to get a way of serving many users or maybe many models in the system. Then another one is we go to an interpretability. It means that humans or users are able to capture relevant knowledge from very many relationships or very many images that are used in the model or that are in the model. Then for the variability in fruit characteristics, It means with the help of AI, machine learning, we are able to develop an automatic fruit classification system with data sets, information for each fruit, and display the images for the final result. Can talk about the need for feature engineering. First of all, feature engineering can help data scientists or maybe the designers of the model by accelerating the time it takes to extract variables from the data, allowing for the extraction of more variables. That means if we don't have these engineering scientists or maybe these people that are supposed to accelerate the time, it means we shall have a gap in our system which will delay the model from doing its functions. Then another research gap we have is the limited availability of datasets. This means that the datasets that we are using could be limited, whereby we are using only three types of fruits, whereby we're using the apples, the bananas, and the oranges. That means if there's a factory somewhere that is supposed to work on maybe pineapples to make pineapple juice, this model will not be useful to them, because in our system, the only data sets we're using, they don't have the pineapples. They have the apples, the oranges, and the bananas, but not the pineapples. That means the other factories or maybe the other processes that require these other different types of fruits, they will have a gap. That means it won't be efficient. That will be a limited availability of the data sets. Next, we'll talk about the methodology. The scope of this project includes identifying and extracting relevant features from the fruit images. All we need is the scope of the problem. Then we need an AI project that we shall be using in our model. Then we talk about the data collection, talk about the data processing. Then we talk about how the features will be extracted. We also have to talk about the model training. So if I can start with the model training, it shall be trained using the deep learning models, whereby this will be working on the extracted features, whereby for the extraction of features, we shall be using convolutional neural networks, CNNs. Then for the data collection and the data processing, then for the proposed AI approach to this problem, we shall be using the deep learning models such as the CNNs to classify fruits based on the images in the datasets. For the dataset we are using, it's from Kaggle. It has been split into two parts: the training and the testing datasets. They have very different images for the testing and the data and the training, which consist of the rotten oranges, the rotten apples, and maybe the rotten bananas. So for each of the datasets, for the test datasets, they have all the fruits in the different forms. They have the apples, the different images of the apples, screenshots of the apples, different screenshots of the bananas, and then for the oranges. And each and every of those follows another set where it has those that are rotten and those that are fresh. That's the data set we are using. It's from Kaggle. It will be shared in the link below. Then we can access the data set. So in conclusion, the model created can be used in real life problems, but basically in the juice processing industries that could be in need of such a model to determine the fruits that they are using to make the juice in their factory. Thank you.